So let us take an example. Here we are given the following data: the age of fathers, the age of sons, and we have to find the regression equations. So to make it this easier, let x represent, or let x be the age of fathers. So this age of fathers become x values or x series, and y be the age of sons. So in the previous example, because we have to find regression equations, we are interested in this and we are interested in this. So what we need to do first is find the regression coefficient of y on x and regression coefficient of x on y. So that is our interest right now, which means these are integral or important in framing the regression equation. So now let us find the regression coefficients. So let us write the x values first. 28. Because if we just go back to the value of the regression coefficient is nothing but the covariance divided by the variance of the independent variable. To find byx, we need covariance of xy and variance of y square, and this is expanded as follows. So we need these values: exy, we need to find the mean, arithmetic mean of x series, arithmetic mean of y values or y series. Then we need to find summation x square for finding out the regression coefficient of x on y. These are the values we need to work with, or we have to find the values for these variables: summation xy, summation y square. So that is what we are trying to do in this sum. That is what we are trying to do in this sum. So let us write down the x values first, which represent the age of fathers: 38, 41, 45. And let us write down the y values, which is 2, which represents the age of sons: 2, 3, 6, 7, 11, 13. And so that to make it so that we don't miss out any value, it is always a good thing to write the formulas on the right hand side so that you don't forget them. It becomes easier for you to know which values you need to find out. So when finding out the variance, or when finding out, sorry, the regression coefficient of y on x, these are the values we need. And when finding out the regression coefficient of x on y, these are the values we need. So we notice here in both these formulas, the numerator is the same, only the denominators are different. Okay, so we need these values. So we need to find the mean, so which means we have to take the summation of these x values. This gives us 216, and summation of y values, this gives us 42. And we also need the mean values, so they are about how many pairs here? 1, 2, 3, 4, 5, 6 pairs. So your n value is equal to 6. So summation the mean value of x will be 216 divided by 6, which is equal to 36. Summation of y values would be ey, n equal to 42 by 6, which is equal to 7. So let us move. So we need to find also the summation of x square. So we'll find the square of the x values. So 28 square is 784, 31 square is 961, 33 square is 1089. So we find the squares of the x values and we add them up and we get summation x square, which is equal to 7984. We also need summation of the y square. Summation of the y square is nothing but the summation of the is nothing but the sum of the squares of y values. So the y values are over here. So what we need to do is square them up and then add. 2 times 2 is 4, 3 times 3 is 9. So the same for the rest. 121, 169. 388. So we already know what are the mean values. For the arithmetic mean of x is 36, so we just, the square of that is about let me check this, 1296, and the square of the arithmetic mean of y, which is 7 squared, that is easy, it's 49. So we know the values, so now we can simply substitute these values in the regression coefficient formula and proceed to find the equations. So the question is to find the regression equations, and we know that there are two regression equations. Okay, we have regression equation of y on x and x on y. So the two regression equations are y minus y bar or y minus y mean, regression coefficient of x on y, x minus x mean, call that as equation 1, x minus x mean, bxy, regression coefficient of x on y, y minus the y mean or y bar, call that as equation 2. So we know the formula of this, we know the formula of this, and we have already solved some of the values needed for calculating these two regression coefficients. So now simply just substitute the values. So first we'll solve first for b, the regression coefficient of y on x. So this means here that y is the dependent variable and x is the independent variable. Okay, so let me just write the formula again because we're doing this for the first time, this sum for the first time, so you get the hang of it. Again, the regression coefficient is nothing but the covariance of x and y divided by the variance of the independent variable, in this case, which is x. So simply substitute the values we have found out. Exy is 1649, the mean of x is 36, mean of y is 7, 1 by 6, summation ex square is 7984, and summation and the square of the mean is, which is 36 square, is 1296. So we work this out. So this will be 1649 divided by 6. 36 into 7 gives us 252. 7984 divided by 6. So that much. So 1649 divided by 6 gives us 274.83 minus 252. 7984 divided by 6 gives us 1330.67, and we subtract 1296. So this is equal to 22.83, 34.67. So So your regression coefficient of y on x is 0.66. Then we go on to find the regression coefficient of x on y. Now you remember the numerator values are the same, only the denominator values are different. So the numerator value is the same, they have the same variables, and we've already calculated that, and it gives us this value 22.83. so we don't have to calculate that anymore, and simply write 22.83 on the numerator. Then we already know what is summation y square, which is 388. 7 is the arithmetic mean of the y values, and the square of that is 49. So 388 divided by 6, subtract 49. This gives us 64.67, subtract 9, which is equal to 22.83 divided by 15.67. So your regression coefficient of x on y is 1.46. So we have solved the regression coefficients respectively of x, of y and x. So now it's simply the case of substituting the values. So substituting the values of byx and bxy in equations 1 and 2. So it's in equation 1. From equation 1 we get, as you remember equation 1, 1 minus arithmetic mean byx, x minus the arithmetic mean, 1 minus 7, 0.66, x minus 36, or y minus 7, 0.66x, 0.66 into 36, 23.76, or y will equal to, if you bring 7 to the other side, it becomes positive, and therefore y is equal to 0.66x minus 16.76, and this is nothing but the regression equation, or is also called the regression line of y on x. So how do you know that this is a regression equation? Because we have the dependent variable on the left hand side and the independent variable on the right hand side. Now similarly, if we were to form a regression equation of x on y, we use equation 2. From 2 we get, so here x minus x bar equal to bxy, y minus y bar. So x minus 36, 1.46, arithmetic mean of y values is 7, or x minus 36, 1.46y minus 7 into 1.46 will give us about 10.22, or if we bring 36 to the other side, it becomes positive, plus 36, or yes, we've already calculated. So simply we have now, therefore x is equal to 1.46y plus 25.78, which is the regression equation of x on y. So now we have x as the dependent variable on the left hand side and y as the independent variable on the right hand side. So that is how you form regression coefficients, regression equations using regression coefficients.